All right, here's one last little quick video for the week if you need help with this starter. So, if we had to complete the area, or sorry, complete the square in terms of area, and we were trying to figure out our missing expression, right? We have to kind of think about how we would make the area of 5 congruent squares, or whatever your number is in your problem. Oh gosh, this is gonna be buggy. Oh, there, it just was slow. Okay. So if I'm thinking about this idea for my 5x squareds, that means I literally have 5 of these like little x squared pictures. Right? I've got 5 of them around, like here's an x squared, here's an x squared, here's an x squared, here's an x squared, here's an x squared. I guess I could have drawn this more concisely, but I just kind of left myself some open space. Now, if I have 60 x's, I've got to divide them evenly between all of these 5 squares. So I'm going to do my 60 divided by my 5. That means we've got 12 x's per square. Now, if you remember, on Tuesday, I drew kind of that little area diagram to kind of start teasing where we were heading here. If we have 12 x's per square, we've got to divide that by the two sides, and that means that we have 6 x's per side. So in this case, if I add onto my square, oh gosh, these are going to have to be small units, but we're going to make, oh gosh, let's just stack it on with a bigger square, sorry. Let's do it this way. So say I've got a bigger square here, and if I add 6 little sections to one side, 5, 6, okay, and then we'll drop a side here. I wish that would work a little bit more evenly. There we go. Good enough. And then if I add 6 x's on this side, well, those last ones got a little big. That's okay. But you get the vibe here that this is going to be an x plus 6, and then another x plus 6, because here I have my 6 x's. And then over here I also have 6 x's. If I have 6 on each side, it's still a square because it's even amount per side. And then that means I have 12 total x's here, right? If I do my x squared, my x times 6, x plus 6 squared, which is my x plus 6 times my x plus 6. We learned from the starter yesterday that this would be x squared plus 12x, and then the 6 times 6 would be the 36 little ones that are hiding down in that corner. I technically would have to have all 5 of these squares would match, right? So these all have to match for me to add up to my 60 x's. So all I have to really do here to figure out this last number is do 5 times my 36 little ones, because if I had that picture 5 times, I would have 36 little squares. And, oh gosh, don't have a calculator on me. 5 times 36, we would get 5 times 6 is 30. And then that's 15 plus another 3 would be 18. So I think it's 180, but you should definitely double check my math. I'm not using a calculator. So that would be my missing value of my expression. I don't know if there's another part of this. If I'm going to scroll down though so I can check. So my missing value is the 180, and it comes from having those 36 little squares, from having my 6 x's per side, because I need 12 x's per square, right, because of that 60 value. So the side length, oh, that's what I could answer, would be my x plus 6. Right, that x plus 6 would be my side length, and I have 5 of them. So 5 times my x plus 6 squared. That's 5 times that x squared plus 12x plus 36. And if I distribute through, oh shoot, but this was a negative 60, wasn't it? Okay, negative 60 just meant that this is a subtract instead of an add. No big deal. So we have negative 6 on each side and negative then 12x, but the negative times the negative would still give us a positive 36, right? So this, if I distributed my 5, good catch there. So this is a x minus 6. Sorry about that. Just haven't done one of these in a minute. So that gives us our 5x squared minus our 60x, because we had to match our original equation, and then plus our 180. So that's what our values would look like. Alrighty. Next question is just asking for our two expressions, right? One is going to be our standard form. Our standard form, remember, is a trinomial. That means that I'm just going to add up all my parts. So a of x is equal to 3x squareds plus 1, 2, 3, 4, 5, 6 x's plus 4. And one that is from a squared binomial would come from rearranging this picture, right? So I'd have my 3x squareds, and that's kind of like connected to our last problem. So we're going to kind of do the same idea of completing the square again, right? So I've got my x squared, and my x squared, because I've got 3 of them. And then I've got to do my x's. So if I divide my 6 x's divided by my 3 squares, so it's literally like rearranging the picture. That means that I have 2 x's per square. So if I extend my, and then I got to divide by 2 again, that cut in half would mean that I have 1 x per side. So if I draw on my bigger squares here, we're really just adding 1 and 1 on each side, 1 and 1 on each side, and 1 and 1 on each side. Let me just add in those dividing lines. Oh shoot, wrong direction. Don't want a diagonal there, just cutting across there. Cutting across there, and cutting across there. So this is the same picture, right? Because here are my x's, my x's, my x's, my x's, just rearranged as squares, and then my little ones in these corners. Now this is where, if I want, the expression should contain a single squared binomial expression. Oh, because we have to have a plus 1? This is throwing me off because we've got 4 little squares. And we shouldn't have to necessarily complete that again. I can double check how they did this, but like my gut is telling me that we would write this as a of x is equal to 3 times, a squared binomial. Yeah, okay, so this is, I am doing it right. It's just getting us vertex form. Remember, which is our y equals a times x minus h squared plus k. I'm sure this is how we have to do this. The important thing to recognize, though, in this picture is that we have one little extra square that is missing that can't be part of our complete squares. So, in terms of our complete squares, we've got this x plus 1 as a square. We've got 3 of them, so that's our x plus 1 part. If we square those values, we end up with all the pieces in the picture, but we only have 3 ones. But we need 4. So this is where we tack on a little plus 1 to make our squares balance. Whew, dang, haven't done one of those in a minute. But hopefully that makes sense. So I rearranged my picture so that they would actually be squares. I have 3 ones based on these pictures and this amount of squares. I need 4 though, so that's where I've got to tack on that plus 1. So this plus 1 is accounting for this needing this other little missing one. Sometimes you might have to take some away. Sometimes you might have to add some. It just depends on how you have to balance your square based on your number of x's and your number of x's per side. All right, hopefully that makes sense. Good luck.